Hello folks, my name is Marcus. I'm a solutions engineer with the Google Cloud Platform team, and I'm here today to talk about preemptible VMs and the project that we have collaborated with Cycle Computing to enable the Broad Institute to do decades worth of computing under 6 hours, leveraging the preemptible VMs infrastructure we have in our cloud platform. So you can read about that project on the Cycle Computing blog. So I shamelessly stole a page from your blog there. And you can see that they were able to build a petascale computer of over 50,000 cores, and they did it in less than 30 minutes using the orchestration software. So it's something really amazing, and it really provides a lot of value to scientists that need to have their results quicker, and definitely quicker than 3 decades is good. And going from 3 decades to a few hours, this is really outstanding. And they done this leveraging the preemptible VMs, which are virtual machines. They're full virtual machines that we have in our platform, but we offer them at a very discounted price because we have huge excess inventory. And this is something that cloud computing brings value, because the cloud providers, they do computing at such scale that they're always planning ahead and deploying ahead, and there's always a lot of excess capacity in the public cloud, and the Cycle product enables you to harvest this excess capacity and to achieve outstanding price performance by leveraging those cheaper resources that are available in the cloud. So what are preemptible VMs? They are short-lived and much lower cost virtual machines. By short-lived, we mean that they are given to you on a lease of 24 hours or less. And according to dynamic conditions in the cloud and demand and supply conditions, the preemptible VM may be asked to be ejected, that you were ejected from the preemptible VM should the cloud need it back. That's part of the trade-offs. But you are only billed per minute of usage, both on preemptible VMs and any other virtual machines in the Google Cloud. So it's still a very good deal. You can use it for a number of hours. And if you have the capability to do checkpointing restart, you can restart the same job in another virtual machine when it becomes available. But in order to be able to use those preemptible VMs effectively, you have to solve a difficult problem, which is that of dynamic reconfiguration. So, and also the initial startup. You have to spin up thousands, in this case in the Broad Institute, have to spin up thousands of virtual machines, and also have to be capable of dynamically reconfiguring the cluster as those preemptions happen. And this is where the Cycle Computing software comes in to do this initial provisioning and the continuous reconfiguration as the preemptions are occurring. So with this combination of the Cycle software that does this difficult reconfiguration, makes it possible to leverage these preemptible VMs and to actually realize the cost savings that are made possible by this platform. So the preemptible VMs, they are suitable for running a wide range of workloads. Basically anything that you can run on a standard virtual machine, you can run on a preemptible virtual machine, with the caveat that you may be preempted and you have to do your work in less than 24 hours. But then the Cycle Computing software will handle this preemption and will reprovision and reconfigure the cluster as appropriate, such that you can make use of the preemptible VMs. The preemptible VMs are actually virtual machines that are provisioned on our compute engine infrastructure. And it has several interesting characteristics that actually enable this kind of utilization, such as sub-hour billing. In the Google Cloud Platform, the virtual machines are billed by the minute and not by the hour. And this is very important in this kind of use case that you are going to do some computing for a few hours, but also by a fraction of an hour. And if you're doing, as in the Broad Institute, thousands of virtual machines, the minutes do add. So if you have a workload that's going to use, for example, 50,000 cores, as in the case of Broad, and you're going to use for 3 hours and 30 minutes, that 30-minute saving that of the full hour times 50,000 cores is a very reasonable savings. So sub-hour minute-based billing is actually very important to make this kind of utilization possible. You can also make usage of a lot of persistent disk capacity. We allow up to 10 terabytes of persistent disk to be mounted. We offer over 44 instance types. And today we actually just released, last week, the capability to customize the instance type. So the instance type is a function of how much RAM you need and how many cores you need. But now those are not cookie cutter anymore. You can actually customize the amount of RAM and number of cores that you need. We have a very advanced network capability inside Google. We have our own software-defined network infrastructure, and we have our own fiber internally at Google. So you have very good transfer rates between the virtual machines and very good latency. And of course, Google has a lot of technology that has been developed internally at Google over their 15 years for doing things and bringing to you things like Google Search and Gmail. And that's all built on top of advanced workload balancing technology that we also make available in our cloud platform. Another advantage of running in the Google Cloud Platform is not only that you can get those high-end virtual machines that I mentioned, but you also, once you're in the cloud, you are able to use the other cloud components that Google makes available. Many of them are derived from Google core technologies, such as the container engine or our high-end databases, such as BigQuery and Bigtable. So those other components, they complement the virtual machine computing capability by allowing our application to also do very high scalable relational queries or leveraging NoSQL queries as appropriate and doing things like PubSub and other technologies that you can read about in our cloud platform page. And as I said, the Google Cloud is also distinguished by the number of technologies that it's making available in the cloud that were technologies developed by Google to run its core business, to run Google Search, Gmail, YouTube. All those applications require a tremendous level of scalability, and they required analytics tools to be developed in order to be able to do things like very large-scale log correlation. For example, in early 2002, 2004, Google had to develop a Google file system to be able to store several copies of the web, and also a MapReduce technology to be able to process logs in parallel, identify bottlenecks in our infrastructure, and so forth. And Google has the strategy of publishing these technologies and contributing to open source. We believe in contributing to science, and we believe that we're going to harvest back as people build upon the technologies that we publish. So all those technologies that I have on the chart were Google technologies that were published and that eventually resulted in white papers and in open source projects that implement the same technologies that are now available in open source. For example, GFS and MapReduce are now available as the Hadoop MapReduce and Hadoop file system. The Bigtable technology is our NoSQL database. It was a white paper that initiated the development of Apache HBase. And the Dremel is our, today externalized as our BigQuery component in the cloud, which is our columnar storage database that's able to do queries of petabytes of data and still give a return time of 5 seconds, constant return time. And the reason it's constant is because the larger the database, the more nodes that are used to do the query. And Google continues in following this strategy of publishing the technologies that are internal to open source and also to make those technologies available in our cloud platform. The latest instances of that have been Dataflow, which is our new generation of MapReduce technology, and also Kubernetes, which is based on the Google container technology, and then Google has made that available in the Kubernetes open source project, and also as a cloud component called the container engine. So you can see that some of the Google core technologies that have been published have resulted in open source projects that have advanced the capability of the open source community. And we really like to see those technologies have been developed as open source, because now that enables a paradigm where the user can deploy those components in-house, on-prem, or on anybody else's provider, and also quickly move to our cloud and leveraging technology cycle computing to make this heterogeneous cloud deployment possible. We believe in enabling the users with the portability to run in any cloud, because we think that like this we're going to have a dynamic marketplace, and the preemptible VMs illustrate that dynamicity. And also because Google has very good performance, and as customers move around, they like the platform that gives them the best performance and the best price performance. And continuing with that strategy of releasing to the open source the core Google technologies that were developed in-house, Google has for several years developed advanced technology for machine learning, and we make extensive use of machine learning inside Google. And that technology is built on a different type of scheduling technology, which is much more flexible than MapReduce. MapReduce can only do a fan-in and fan-out and fan-in of computations, while TensorFlow, which is this new scheduler technology that we have developed, is based on a DAG, a direct acyclic graph programming model that's able to do much more complex sequence of operations. And it basically uses data dependencies to determine what operations are ready to be executed in a distributed environment. So last week, November 9th, Google has released TensorFlow to the open source community, once again releasing core technologies to open source. And you can expect that it will also be implemented in our cloud as a component of the cloud platform. And this is very timely, actually, because at the opening of HPC, if you heard it at the talk by Intel at the opening, they have mentioned how machine learning is changing HPC and how HPC is changing machine learning. And we see that those two technologies are getting together, and this is very exciting. I think we have a lot to contribute to the field of HPC, given our expertise in machine learning. And reverse-wise, we're also looking forward to learning from HPC and making our machine learning even better. Thank you.